Today we'll discuss about some ascending tracts. We will discuss tracts in the dorsal white column and tracts in anterior and lateral white column. At the end of this class, you will be able to know about origin, situation, extent and termination, function and effect of lesion of dorsal column medial lemniscus pathway and spinothalamic tract. Ascending tracts or sensory tracts. Major ascending sensory tracts, they have been grouped as dorsal column sensory pathway, this one. Second one, that is anterolateral sensory pathway, and third one, that is dorsolateral sensory pathway. Now, ascending tracts in the dorsal white column, mainly two tracts are there. One, that is fasciculus gracilis, you can see here medially, and fasciculus cuneatus laterally. Fasciculus gracilis is also known as tract of Gall, and fasciculus cuneatus is known as tract of Burdock. Tracts in the anterior white column, this is anterior spinothalamic tract, this one, and tracts in the lateral white column, they are blue one, you can see lateral spinothalamic tract, this one, dorsal spinocerebellar tract, this, and ventral spinocerebellar tract. So these are all these tracts, that major sensory tracts. You can see here this one, first one, that is spinothalamic tract, this one, lateral and anterior spinothalamic tracts. This is medial lemniscus, also known as dorsal column tracts, and these are anterior and posterior or ventral and dorsal spinocerebellar tracts, you can see. Now, some other tracts, ascending tracts, they are spinotactal tract. You can see here in the diagram, this pink one is spinotactal, that carries impulses from spinal cord to the superior colliculus in the midbrain. Other is spinoreticular tract, this black one, spinoreticular tract, this one, and spino-olivary tract, that is from spinal cord to the inferior olivary nucleus in the medulla, and this is blue colored, you can see in the diagram, that is spino-olivary tract. Another is spino-vestibular tract, it is not shown in the diagram, that is from spinal cord to the vestibular nucleus present in the medulla oblongata. Now, we start our discussion with medial lemniscus or dorsal column tract. As the name suggests, dorsal column tract, they are located in the dorsal column. Names of the tracts, as we have discussed, fasciculus gracilis and fasciculus cuneatus. Fasciculus gracilis is this red one, you can see here, this red one is fasciculus gracilis and this blue one is fasciculus cuneatus. Both of them, they are located in the posterior white column, which is also known as posterior funiculus. Fasciculus gracilis is situated medial to the fasciculus cuneatus, and both of this fasciculus gracilis and cuneatus, they are separated by posterior intermediate septum, as we have discussed. Posterior lateral septum and posterior intermediate septum, they are present in the spinal cord, and this posterior intermediate septum is present in cervical and upper thoracic segments. Now, fasciculus gracilis and fasciculus cuneatus. Let us discuss origin, course, termination of these tracts. These tracts, they originate from DRG, that is dorsal root ganglion. You can see here in the diagram, this is the dorsal root ganglion. We have already discussed ganglion, it is the collection of cell bodies outside the central nervous system. This is known as dorsal root ganglion. Why? Because it is located near dorsal root. This is pseudo-unipolar ganglion. Means it has one pole from which one process arises, which is divided in two processes. One of the process becomes dendrites and other process becomes axon. And now this axons, they carry the information towards the central nervous system. So the neuron is like this, dorsal root ganglion. You can see here, this is the neuron, pseudo-unipolar. So these are dendrites, they carry information, and this is the axon which carries information towards the central nervous system. Now, one of the important characteristic of this tract is, most of the tracts we have discussed, they are made up of second order neurons. As we have discussed, three order neurons are there, first, second and third. First order neuron is always in all the tracts dorsal root ganglion. And we have discussed all the tracts, they consist of second order neurons, because this first order neuron ends in the dorsal horn of the spinal cord, and from which second neuron starts. But in this tract, fasciculus gracilis and cuneatus, these tracts, they are formed by first order neurons, that is dorsal root ganglion, axon of the dorsal root ganglion. Okay. Now, course of this tract, that is situation, extent and termination. As we have discussed, this is the first order neuron which produces, as we have discussed, this tract fibers, they consist of first order neuron, that is dorsal root ganglion, and these fibers, they are large myelinated fibers. They are A alpha and A beta fibers. They enter in the spinal cord mainly from the medial division of the dorsal nerve root. Now, these fibers, they run in the spinal cord through dorsal column as fasciculus gracilis and fasciculus cuneatus. You can see here this green one, that is fasciculus gracilis neurons. Okay. Now, directly from the dorsal root ganglion, these fibers, they enter in the spinal cord, and now they directly enter into the dorsal column. These neurons, they do not synapse in the spinal cord. Now, some fibers of the medial division of the dorsal nerve root, they descend through posterior white funiculus. Sometimes these fibers, they do not directly enter, they may ascend or descend, and they form a small tract which is known as fasciculus interfasciculi. That is, it connects two fasciculi, gracilis and cuneatus, and this tract is also known as comma tract of skulls. Now, situation, extent and termination of dorsal column tract. You can see here, these tracts, they enter in the spinal cord. It forms fasciculus gracilis in the lower part. So, from lower part, the fibers entering, they are pushed medially, and this tract fibers entering in the spinal cord through lower segments, they form fasciculus gracilis. So, in the lower segments, you can see fasciculus gracilis occupies the whole dorsal column. Okay. Then, as we ascend up, you can see these are the sacral segments, then lumbar segment, more fibers they enter, in the thoracic segments, more fibers they enter, and in the cervical segment, again more fibers they enter. So, you can see here in the sacral and lumbar segments, the fibers are fasciculus gracilis only. Am I clear? Fasciculus gracilis tract is formed by fibers from lower extremities. Above lumbar segments, you can see next tract enters. So, this fibers of fasciculus gracilis, this one, this two medial one, they are pushed medially and they form fasciculus gracilis, and in upper segments the fibers they form another bundle, fasciculus cuneatus. These are fasciculus cuneatus fiber. Okay. So these are fasciculus gracilis and these are fasciculus gracilis and these are fasciculus cuneatus fiber. Here you can see in the dorsal column here, medially fibers from sacral and lumbar segments are there, and laterally fibers from thoracic and cervical segments. So fibers from sacral and lumbar segments, they form fasciculus gracilis, and fibers from thoracic and cervical segments, they form fasciculus cuneatus. You can see here in the diagram. Medially sacral and lumbar segments is equal to fasciculus gracilis, laterally thoracic and cervical segments, they form fasciculus cuneatus. Again the same thing is depicted here. You can see medially fibers from the leg, fibers from the trunk, then fibers from the arm. So as new fibers they enter, lower fibers they are pushed medially. So here again the same thing, fasciculus gracilis consists of fibers from the lower extremities. They are from the lumbar and sacral segments, and fasciculus cuneatus consists of fibers from upper segments. They are cervical and thoracic segments. Okay. So this is about first order neurons of our tract. Okay. Now we come to second order neuron. Now this first order neurons, they end in the medulla oblongata. You can see here in the medulla oblongata, these fibers, as the fibers are first order neuron, they do not cross, they ascend on the same side, and they end in the medulla oblongata in the nucleus, that is nucleus gracilis and nucleus cuneatus. From this nucleus gracilis and nucleus cuneatus, you can see here second order neurons they arise. Now this second order neurons, they are divided in two groups. One, that is external arcuate fibers, and second is internal arcuate fibers. Now these external arcuate fibers are further divided in two groups, dorsal and ventral groups. You can see here dorsal group fibers, they pass, this one dorsal group, this one, they pass via inferior cerebellar peduncle of the same side, and they end in the cerebellum. You can see here. Whereas ventral group fibers, they cross to opposite side. Here it is not properly shown, but they cross to opposite side and they pass via inferior cerebellar peduncle of the opposite side and they end in the cerebellum. Now internal arcuate fibers, they arise from this nuclei, as we have discussed, nucleus gracilis and nucleus cuneatus. They are present in the medulla oblongata. Now this second order neurons, you can see they cross to opposite side, this side. Then in the medulla they ascend as internal arcuate fiber. You can see here, and they are known as medial lemniscus tract. Medial lemniscus tract means fibers of fasciculus gracilis plus fibers of fasciculus cuneatus. They ascend as one lemniscus, and this is medial lemniscus. Now this medial lemniscus ascend upward and it ends in the thalamus. So second order neurons, you can see here in the diagram on the opposite side thalamus, they end. In which nucleus they end? They end in the ventro-posterolateral nucleus of the thalamus. You can see here this is the thalamus and they end in ventral posterolateral nucleus of thalamus. Now third order neurons, they arise from thalamus. Which nucleus? We discussed ventro-posterolateral nucleus of thalamus. Now this neurons, third order neuron, they pass through internal capsule and corona radiata, and they reach to the sensory cortex here. Sensory cortex of cerebrum. The area number, somatosensory area 1, number is area 3, 1 and 2. The numbers are given by Brodmann's classification. Now, so the fibers, you can say, they start from the dorsal root ganglion, first order neurons, they ascend up in the dorsal column, ends in the nucleus gracilis, nucleus cuneatus, from which second order neurons they start. This second order neurons they cross and they ascend up as medial lemniscus, and they end in the thalamus. From thalamus, third order neurons they arise and they end in the sensory cortex. This diagram also shows the same thing that we have discussed. Dorsal column pathway, same thing, first order neuron, dorsal root ganglion, ascend up, end in the nucleus gracilis cuneatus in the medulla, ascend up, second order neurons, they start from the medulla, they cross to the opposite side, ascend and end in the ventro-posterolateral nucleus of the thalamus, from which third order neurons they arise and they end in the sensory cortex. This one, primary somatosensory cortex in the parietal lobe. Now we discuss what are the functions of medial lemniscus, dorsal column tract. Functions are, they carry sensation of fine touch, tactile localization, tactile discrimination, stereognosis, proprioception, kinesthetic but conscious kinesthetic sensation, and vibration sensation from same side. So if there is lesion in the tract, in the spinal cord, what happens? Same side, all the sensations they are lost because the tract crosses after medulla oblongata, you can see here. After medulla oblongata, nucleus gracilis and cuneatus, from which second order neurons they arise and they cross. Okay. What happens when there is lesion of this tract in the spinal cord? There is loss of all this sensation from the same side. Which are the sensations? They are fine touch, tactile localization, tactile discrimination, stereognosis, proprioception, conscious kinesthetic sensation and vibration. Spatial orientation of the nerve fiber in the dorsal column medial lemniscus system. There is spatial orientation of nerve fibers from individual part of the body. In the dorsal column, lower parts they lie towards center, you can see here, and upper parts they lie laterally. So here medial most, sacral parts, then lumbar parts, thoracic and cervical parts. In thalamus also there is spatial orientation. Tail end of the thalamus is represented by the lateral fibers here, and head end that is represented by the medial portion of the ventrobasal complex. Next is anterolateral pathway. First order neurons for the anterolateral pathway, they arise from A delta and C fibers. They are small myelinated A delta and unmyelinated C fibers. You can see here A delta fibers. They carry sensation from mechanoreceptors, nociceptors and cold receptors. And these fibers, they end in lamina 3, 4 and 5, you can see, as well as lamina 1. Whereas C fibers, they carry sensation from nociceptors, thermoreceptors and mechanoreceptors, and they end in lamina 1 and 2. Anterolateral pathway carries sensation of pain, temperature and crude touch. Now here another terminology, tract of Leger. What is it? After entering in the spinal cord, you can see here, this is the first order neuron, dorsal root ganglion, this one. After it enters in the spinal cord, they separate into short either ascending or descending fibers, and they form dorsolateral tract of Leger, and they end finally on the nucleus proprius of the spinal cord. They end on this nucleus proprius of the spinal cord of either above or below sections. Okay. Some fibers they end on the short interneurons in the lamina 2, that is substantia gelatinosa, which connects them to the nucleus proprius, and this tract which is formed by the first order neurons, that is known as tract of Leger. This first order neurons they end in the dorsal horn of the spinal cord in the nucleus proprius, from which second order neurons they arise. You can see here in the diagram, this is first order neuron and second order neuron arises. Now this second order neurons they cross to the opposite side and they ascend in anterior and lateral white column. They ascend upward, they reach up to the thalamus, and the tract which is formed by this second order neuron is known as Spinothalamic Pathway. Now we first discuss about ventral spinothalamic tract. As the name suggests, it is located in the anterior white column. Now origin, the fibers of this tract they arise from dorsal grey horn from the lamina 1, 4, 5 and 6, and they form second order neuron. You can see here, this is the second order neurons, they form this tract. Now these fibers they ascend in the posterior grey horn for 1 to 2 segments here as we have discussed, and they form tract of Leger also. Okay. Now here the fibers of the second order neurons which forms this spinothalamic tract, anterior spinothalamic tract. Now this tract ascends in the anterior white column. Okay. And this spinothalamic tract they form spinal lemniscus. Now what is this spinal lemniscus? You can see here. So the spinal lemniscus, it is formed by anterior as well as lateral spinothalamic tract. So this is anterior one. Same way here also lateral spinothalamic tracts they also ascend. So these two tracts they form spinal lemniscus. Termination, these tracts they end in the ventro-posterolateral nucleus of thalamus here, and from this nucleus, ventro-posterolateral nucleus, third order neurons they arise, and this third order neurons they end in the sensory cortex. Function, these tracts they carry sensation of crude touch, tickling and itching sensation. Important characteristic is these tracts they give collaterals to the reticular formation, and because of this collaterals to the reticular formation, when this tract fibers they are stimulated, they result in arousal. Function, as we have discussed, these tracts they carry sensation of crude touch, tickling, itching. Effect of lesion, if there is unilateral lesion of this tract, there is loss of sensation like crude touch, tickling, itching sensation from the opposite side. You can see if here there is a lesion in the tract, so this side of sensation of crude touch, tickling, itching they are lost. You can see here. Next is lateral spinothalamic tract. They carry sensation of pain and temperature. As the name suggests, lateral, they are located in the lateral white column. You can see here, they ascend through the lateral white column. Origin, they arise from the dorsal grey horn, lamina 1, 4, 5 and 6. First order neurons, they are same as we have discussed, dorsal root ganglion, this one. The fibers of the dorsal root ganglion, they end in the dorsal horn of the spinal cord, lamina 1, 4, 5 and 6, from which second order neurons they arise. This second order neurons they cross to the opposite side and they ascend in the lateral white column. Now here also there is spatial organization. Here also the fibers from the sacral and lumbar segments, they are present laterally. You can see here in this track. Lateral most fibers are sacral, then lumbar, then thoracic, and then cervical. So lateral most sacral fibers are there, then lumbar, thoracic, and cervical. So the fibers are represented as cervical to sacral segments from medial to lateral side. Lateral spinothalamic tract along with anterior spinothalamic tract, they form spinal lemniscus in the brain stem. You can see these two tracts, as we have discussed, one is anterior spinothalamic and other is lateral spinothalamic. They ascend upwards in the midbrain pons medulla and they form lemniscus, which is known as spinal lemniscus. Lateral spinothalamic tract also they end in the same ventro-posterolateral nucleus of thalamus, from which third order neurons arise and they end in the sensory cortex. This is the diagram showing origin, course and termination of spinothalamic tract, lateral spinothalamic tract. You can just revise. Dorsal root ganglion, it is the first order neuron, ends in the dorsal horn of the spinal cord, from which second order neurons they arise. The second order neurons they cross, they enter in the lateral white column, they ascend up. These fibers they end in the thalamus, from which third order neurons they arise, and this third order neurons they end in the sensory cortex. Functions of lateral spinothalamic tract, they carry pain and temperature sensation from opposite side of the body. Effects of lesion, when unilateral lesion is there in the lateral spinothalamic tract, there is loss of pain and temperature sensation from opposite side of the body below the level of lesion. This is again the same thing, lateral spinothalamic tract pathway. Now, this spinothalamic tract, as we have discussed, anterior as well as lateral, they give collaterals to the reticular formation. Now, what is this reticular formation? It is a network of neurons present in the brain stem. It has various vital functions. One of the important function of the reticular formation is it is concerned with the arousal. And this is the reason when lateral as well as anterior spinothalamic tract, when they are stimulated, reticular formation gets activated and person becomes awake. Another applied physiology is anterolateral chordotomy. What is it? Whenever there is a severe pain of carcinoma, in those conditions when the treatment is not available, in those conditions, anterior and lateral cord of the spinal cord, they are removed or they are sectioned. That is to decrease transmission of the pain. Now, characteristic of transmission in the anterolateral pathway and dorsal column. Anterolateral pathway is a crude type of transmission as compared to dorsal column system. Which are the characteristics of anterolateral pathway? One, that is velocity of transmission is 1/3 than dorsal column pathway. So, fibers are small, unmyelinated, therefore velocity of transmission is less. Second, spatial localization for anterolateral pathway, that is poor, and it causes poor degree of localization. In the anterolateral pathway, there is gradation of intensity judged. They are also less accurate. We cannot accurately say exact part where we have pain as compared with the dorsal column system. Another characteristic feature is ability to transmit repetitive signal is also poor in case of anterolateral pathway, whereas ability to transmit repetitive signals, that is good in case of dorsal column pathway. So this is all about dorsal column medial lemniscus system and anterolateral pathway. Thank you.